Hey, what's up, Franklin West? I've got a video for you today on how to solve linear equations. This is at the proficient level at a grade 9 course at BFA Fairfax. But what I've seen in other classrooms is there are students and curriculum that are also solving linear equations. So if you are younger than the ninth grade, but you want a challenge, feel free to continue to watch.
All right, so we are going to do 3 problems today. Remember, this is the proficient level in a Math 1 class at BFA Fairfax. But if you are past Math 1 but need a refresher, continue to watch. And if you are curious what lies ahead or you're just hungry for more, well, you're welcome as well. So we're going to take a look at this first equation here. We have variables on both sides, which are the 5x and the 12x terms, and we have constants on both sides, so the 3 and the 67. But we have to watch these signs carefully. That's adding 3, but at this level, that's now, we have to recognize that that's a positive 3. Just like we know that's a positive 5x, even though there's no sign there, that's something we've known our whole lives without having to really be conscious of it. That's a positive 12x, and that's a negative 67. And doing a scan like this and knowing the true value of each term will really help guide you on how to solve an equation, because we're really trying to undo things. We're trying to undo subtracting 67, for example. And so how do you undo subtraction? Well, you'll add it. And so that's what we'll do here. We're going to add 67. Now, I could have consolidate, because what I'm going to do is consolidate this negative 67 with the positive 3. I could have done the opposite of adding 3. I could have subtracted 3. But what that would have led me to do is deal with really large, or really small but large looking negative numbers. And I like to avoid that wherever I can. So this is adding 67 to this side also. So we did nothing with the 5x. So that just comes down in our next line untouched. But now 3 plus 67 becomes 70. Whoop, getting large writing here. Now, I did not, again, do anything with the x term, so the 12x comes down unchanged. But notice what happens here, and this is the goal. When we are trying to undo what's there through adding and subtracting, we are creating zeros. And so these two terms, I'll put a 0 over them. They cancel each other out, and that was the goal, because that is what allowed us to move the 67 over to the other side. Because again, in algebra, this is all about balance. That equal sign is critical. Whatever's on the left has to stay truly equal to whatever's on the right at all times. And so whatever we do to one side, we must now do to the other. So now we're going to take a look at our x terms. Those should be consolidated also. So because I moved my numbers, my constants, over to the left, I now should move my variable to the other direction. That way I'm steadily isolating the x value. So that's a positive 5x. So we're going to subtract that over to the other side. So again, whatever I do to one side, I'll do to the other. I've instituted now, or created, a 0 here. So that term has disappeared as designed, as planned. And that leaves me now with a 70 is equal to the difference of this 12 and 5. So that equals 7x. Now, the other thing to keep in mind is whenever you see a number and a variable pushed right up together, that's always multiplication. We always and forever get to assume that. And the way we undo multiplication is division. And at this level, we want to make sure we're using the division bar, rather than, remember this, that division symbol. We don't want to do that. No more division symbol. We'll just erase that. So now when we do this division by the division bar, 70 divided by 7 is 10. And 7 divided by 7 now is 1. It's often where students, if they're going to make a mistake here, they call it 0 because you're thinking of a 7 and a -7 canceling out. But that comes when we're adding and subtracting. When we multiply and divide, what we're actually doing is we're trying to create a value of 1. And so that way we're left with 1x, which is the goal when we're solving these equations. Now, we don't have to write a 1 in front of that x, but we could. Okay, and so now we have x is equal to 10. What we should do, and I'll slide the screen over, is we should do a check. Whoops. A check is another level of being able to, doing cursive with a mouse. So we are going to do this check. This is another level of being able to demonstrate that you are proficient in math. It's always good to be able to double check our thinking. And we as math learners don't need to rely on a teacher to tell us if we're right or wrong or an answer key. We actually can check our own work for ourselves. And that's really, really cool, really empowering. So here's how you do that check. We are saying that x is a value of 10. And so we return back to the original equation. And we are going to rewrite that whole equation. But now I'm not going to ever write the x because we're saying x has a value of 10. And so using parentheses in this step, because this is substitution, and I really recommend for really accurate, mistake-free work, whenever you're substituting, use parentheses around the value that you're plugging in, because otherwise you really risk missing a distribution potentially. Without that. So here we are writing this out. So notice, oh, look what I did. I put in there. Let's get rid of that. So this needed to be, you guessed it, a 10. Okay, so I've substituted 10 in for all my x's, and now I just follow my order of operations, your PEMDAS, your parentheses, exponents, multiplication, division, addition, subtraction. Remember, some of those, like multiplication and division, are equal priority. You'll do them left to right as you encounter them. Addition and subtraction are the same way. So when I see a number or some term right up against a grouping of a parenthesis here, it is multiplication always. And so that's 50. Oop, my mouse. There we go. Plus 3. And that's equal to 12 times 10, which is 120. Oh my goodness. Minus 67. Okay. Let's see. Let me see if I can erase what almost, there you go. Almost looked like an 8 accidentally. Okay, so 50 plus 53, 50 plus 3 is 53. And then 120 subtract 67. You can scratch that out on paper. You can challenge yourself with mental math, or you can pop it into a calculator and you'll find that it actually equals 53. And so this right here, because the left truly does equal the right, we have completed our check. And what we've done is we've proven that x does in fact equal 10. So I'm worried this video is going to get a little long, so I'm going to cut it here. And then these other two equations, which I'll show you briefly. Here's the second equation, and the third. See how it layers in a bit more challenge. We'll come back to those in the next video.
So I hope that video was helpful in helping you understand that content. If you are interested in knowing more about this or another topic, do not hesitate to reach out to me. You can always email. If you have YouTube permissions from your parents, you can comment below and tell me what topics you would like to have added into my video list to help you with your continued math learning. And don't forget, if there is science stuff that you need some help with, I can work on providing materials for that also. So I hope it was helpful. Good luck in all that you do. You're all wonderful people.